our last video, we looked at the structure of bone. This right here is compact bone. Compact bone is found on the outside of all bones and in the diaphysis of long bones, whatever those are and whatever diaphysis is. So it has this repeated structure called an osteon. So this is the osteon, and in the center of the osteon is a central canal that has blood vessels in it. Now, the osteocytes are found in these lacuna, and they're connected by these little tiny canals called caniculi. They're holding hands. So nutrients pass from the central canal through the caniculi. So this is using an oil immersion lens. I think it's 1,000 times. Here is the lacuna. The osteocyte's been destroyed by the silver nitrate stain. And we have the caniculi connecting the central canal to the lacuna. And here's a lower power. The central canals actually have blood vessels that connect them called Volkmann canals. And you can't really see the lacuna that clear because this is out more. Then we looked at spongy bone. Spongy bone has these gaps. That's why it's called spongy. It looks like a sponge. And we have these trabecula that are going everywhere. And these provide structural support. We can still see the osteocytes in the lacuna. This is an H&E stain, so the osteocyte got to live. And I know I called those osteoblasts. I'm wondering if those were osteoclasts last time. So we're going to look at the parts of a long bone. These are long bones, by the way. And state the function of red and yellow marrow, identify the parts of a long bone, where the cartilage is, and so forth. So let's actually look at my little picture. So bones are classified on their shape. They're classified 4 ways. There's long bones. These would be long bones, even though those aren't very long. The short bones, these are short bones. Flat bones, and irregular bones. So let's look at these bones. So this is a long bone. If we look at it, it is longer than it's wide. So it is, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 squares across and up or in length and only 3 squares long. So these are 2 of the metatarsals, and they're long bones, even though they're not technically that long, because they're longer than they're wide. Now, long bones are also circular, so see how this is a circular shape. Now, we have, over here, 3 short bones. This bone is pretty much a square. This bone is pretty much a square. This bone, it is a square. So these are all carpals. This is one of the tarsals. It is square in shape as well. So this would be a short bone. Short bones are pretty much square in shape. This bone here is the hamate. Now, if in the lab I could really confuse you and say, is this a short bone or a regular bone? Well, it's pretty much a square-shaped bone. So it's classified as a short bone. So what about this distal phalange? What would that be? Well, it's longer than it's wide. Even though it's a little tiny bone, I think it's maybe 3/4 of an inch, it's considered a long bone because it's longer than it is wide. Okay, now I have 2 bones. I have on this side the nasal bone, and this side a distal phalange. Now the distal phalange is circular. I turn it around, it looks circular. The nasal bone is longer, but see how it's flat? That would be a flat bone. Now another big difference is if I cut this in half, it would have something called a marrow cavity in it, where the nasal bone would be all spongy bone inside. So again, here is another phalange. It's circular, so it would be a long bone, even though it's the same size as the nasal bone. The nasal bone is considered a flat bone because it's flat. So flat bones are flat. They're 2-dimensional, pretty much. Long bones are longer than they're wide. A short bone is square in shape. So our lunate bone right here is a short bone. So this thing, well, let's look at it. It's a weird shape, but oh, look, it is fairly flat. So this, see how it's flat as we go around? This too would be a flat bone. So the flat bones are flat. What do you call this? Well, it's two-dimensional, so it's a flat bone. Okay, what about these two? This bone, oh look, it's only two-dimensional, so what bone is it? It's a flat bone. It's a rib. Now this bone, let's see, that's round. So this is a clavicle. It would be considered a round bone. Okay. Let's work on our naming system. This bone right here, it's basically a square. It's a knee bone, so it's considered a short bone. Now, this guy, what the? It's a vertebrae, but it has this odd stuff poking off of it. Wait, let's grab another vertebrae. Oh, this looks flat right here. Oh, that looks round. What the heck should we call this one? What the heck is this? It is the atlas, but what is it? It doesn't fit into any of our categories. So let's look at our notes again. So, long bones are longer than they're wide, and they tend to be circular. Short bones are square-shaped, so the capitate would be short. I believe this is the talus. That would be a short bone. Flat bones are thin and flat, lightweight. And, oh, it looks like the anatomists got tired of trying to name things. They wanted to go out for their beers, so everything else is irregular. So these vertebrae that I've been showing you, they're irregular. If I were brave enough to take that skull completely apart to get to this bone, I'm not brave right now. This would be an irregular bone. They couldn't classify it. So, for lab today, I'm going to have you sort bones into categories. I'm not going to have you sort all 206 of the bones in our skeleton, but I'll have you sort a few of them into long and short, and I will be sneaky and throw some phalanges and metacarpals and metatarsals in there as long bones. So, we're going to talk about the parts of a long bone. So this is a long bone right here. So here is our long bone down here. It is longer than it is wide. Now, the ends of it are called epiphyses. Actually, first, it's surrounded by a periosteum. So most of this long bone is surrounded by a periosteum, like so. And yes, I'm drawing my doggy bone. Now, the very end of this, and this is periosteum is dense connective tissue, the very end is actually going to have some articular cartilage, and I'm just putting that in so it has its place. And we have the articular cartilage up here. Now, what's surrounding all bones? It is compact bone. So I'll draw in the compact bone. So we have our doggy bone. Uh-oh. So we have our doggy bone here. Now, these ends of the doggy bone are the epiphyses. And what kind of bone was in there? That's right, spongy bone. So we have spongy bone in these epiphyses. And the epiphysis is the end. So this end of the long bone is the epiphysis. And there are two of them. So this end would also be the epiphysis. And it is made as spongy bone. Now we have the shaft here. This is the shaft. Let's change color to green. Green's a good color, I guess. This right here would be the diaphysis. Our long bone right here, this region right here would be the epiphysis. This would be an epiphysis. And then the shaft right here is the diaphysis. So far so good. Now notice I left a blank there, and I left a blank on my picture. Long bones grow at this structure called the metaphysis. It's actually a joint in children that separates the epiphysis from the diaphysis. So we have metaphyses. And spell check will really try to change it to metaphysics, but it's the metaphysis. And this is where I really don't like pronunciating the Latin word right. I like calling it the metaphysis, because I could spell meta and I could spell physis. Metaphysis, I'm not so sure about. So, in children, this is actually going to be hyaline cartilage, and it's the growth region where it can elongate up and down. In adults, there's going to be a seal there. It's a line the growth plate closes over. So the periosteum is going to surround the long bone. So this would be the periosteum. It's dense, irregular connective tissue. Protects, holds blood vessels, has the osteoblasts, can't forget that. The two ends, this end and this end, are the epiphyses. And it beams upon spongy bone covered in compact bone. It is enlarged to strengthen joint, to allow for joints, for ligaments. So here, that is the end of the ulna. It is enlarged right here to form a hinge joint. It forms a pivot joint right there. It has all these structures where ligaments attach. So it has all these cool structures, which we get to learn about in today's class. And it's going to have red marrow in it. Red marrow makes blood cells. Now, this region, that's the growth plate. That's the metaphysis. And in children, it's hyaline cartilage. It's actually forming a type of cartilaginous joint between the ends. In adults, it closes over and fuses. The diaphysis is the shaft. Now notice it has an empty cavity. That is the medullary cavity. Remember, the medulla was the middle of the hair? Well, the medullary cavity is the middle of the bone. We're going to see medul in the middle of everything in this class. Now, the medullary cavity is going to have yellow marrow, which is just a fat store. So, the medullary cavity is the marrow cavity. It's in the middle of the diaphysis, and it's lined with endosteum. So remember my picture, which I deleted from the whiteboard. We had the periosteum on the outside. Well, this is lined with the endosteum. So endo is inside, peri is the outside. It contains osteoblasts, or the endosteum contains osteoblasts. And in adults, the medullary cavity has yellow marrow. So you have two flavors of bone marrow. Both of them taste disgusting. I grew up in the 70s. I swear parents try to give you every single possible food choice, and marrow was one of them. I rank it up there with liver and lima beans were disgusting. So red marrow is going to be found in the spongy bone of the epiphysis. It is going to be blood cell production. In adults, this eventually becomes fat, but you still have it in your hips. You have it in your flat bones as well. Yellow marrow is in the medullary cavity, and it's mostly fat. So I used to get fresh bones from our local butcher, and I had to go early enough in the day because apparently this lady would go get the bones for her dog. I would get them for my anatomy classes. She would get them for her dogs because of to chew on and to eat the fat. Pretty sure her dogs all died of coronary disease because of all the fat in the medullary cavity. Now lastly, I drew articular cartilage on my picture. This would be the articular cartilage, and this is articular cartilage. It is hyaline cartilage. It's decreasing friction. So if this bone was a real bone, you'd have hyaline cartilage right there. And it's going to decrease the friction with this bone that thinks it's really funny. It's called the humerus. It's not funny at all. So, I want you to define these terms. I want you to define epiphysis, diaphysis, metaphysics, spell check is struck again. Don't define metaphysics, by the way. Metaphysis, endosteum, and periosteum. And I will go over that in our next video. Thank you.